Alright guys, today we're going to work with fractions and decimals and moving back and forth between the two and relating the two. Now, first thing we're going to talk about is writing fractions as decimals. Now there's a couple different ways we can do that. It kind of depends on the fraction you're given. Now, what you have to kind of remember for the first way is the fact is your place value. Like if we have a number, 0, and then a decimal point, your first decimal place is the tenths place, second decimal place is the hundredths place, third decimal place is the thousandths. So you can relate that to kind of the first one. If you have a fraction that has a denominator that can even go into 10, and that relates to the tenths place, 100, so that's the hundredths place, and then this is a typo here, this should be 1,000, guys, so stick a 0 in there. The 1,000 relates to that thousandths place, and we could keep going with that. These are the main ones that we're going to be using. Alright, so if you have a fraction that goes evenly into one of those numbers, you can use equivalent fractions to find the decimals. For example, 1/2. 2 goes evenly into 10. Actually goes evenly into all those numbers, but we always want to start with like the smallest number that makes sense. So if we can get a denominator of 10, it's really easy to get it into a decimal. Now, equivalent fractions, you got to look at what do I multiply the denominator by to get that 10? Well, I multiply it by 5. But to keep it equivalent, I also have to multiply the numerator by 5, because multiplying by 5 over 5 is basically the same as multiplying by 1. 5 over 5 is 1, so it's really keeping it the same. We're just changing the form a little bit. Now, 1 times 5 is 5, so we have 5/10, so that's really easy to write as a decimal. It's going to be 5/10 because it's in the tenths place. Now this can also apply for negative fractions, like -3/4. Okay, 4 goes evenly into 100. All right, and it's a negative fraction, so it's going to stay a negative fraction. And here I'd multiply 4 by 25. All right, to get 100, so I got to multiply the 3 to keep it equivalent. We got to multiply numerator and denominator by the same thing. So I'm looking at a -75 hundredths. Now, since this is over 100, that means I need to end in the hundredths place. So it's going to be a -75 hundredths. We're going to have 2 places past the decimal. Now, unfortunately, not all fractions have a denominator that evenly go into 10, 100, or 1,000. So we have to have a way that works no matter what your fraction is. And when you have any fraction a over b, as long as a is not 0, you can't have a 0 in the denominator, you can write the fraction as a decimal by dividing the numerator by the denominator. Or in other words, you're going to be doing a divided by b, because ultimately fraction is division. And that's kind of nice because dividing always works no matter what. And if the division ends or the remainder is 0, it's considered what we call a terminating decimal. So terminating meaning it ends. So it has an end to it. All right. Let's see. Let's go through a couple examples, but let me move this up. I'm gonna have to erase some things before I can move it up, or else it'll get in our way. Let's see. Let's get rid of these words so we can move this up. Okay, let's move this up so we have a little more room. Okay, so if we're going to change this 7/8 to a decimal, what we're going to do is we're going to do 7 divided by 8, the numerator divided by the denominator. Now obviously 8 doesn't go into 7, so this is where we're going to add a decimal point and a 0. And I'm going to bring that decimal point up in my answer. Now, 8 can't go into 7, but can go into 70. It'll go in 8 times. 8 times 8 is 64. And when we subtract, we get 6. Now, I still have a remainder, so I'm going to add another 0 and bring it down. Now, 8 will go into 60 7 times. 7 times 8 is 56. When we subtract, we get 4. Not quite done yet. Let's add another 0, see what we get. Now, this looks nice. 8 will go into 40 exactly 5 times. So we get 40, and then there's no remainder, so we're done. It's 875 thousandths. Okay, so let's look at another one. 3/16. Okay, we're going to do numerator divided by denominator. 3 divided by 16. We're going to have to add another decimal point and a 0. Now, bring my decimal up in my answer right off. 16 can go into 30. I'll go in once. 1 times 16 is 16. We subtract, we get 14. So we're obviously not done yet. We'll have to add another 0, bring it down. 16 will go into 140. Actually go in like 8 times. 8 times 6 is 48. Carry the 4. 8 times 1 is 8, plus 4 is 12. We subtract here. We get 12. Add another 0. Bring it down. Now I just saw 8 times 16 was 128, so I'm just going to go 1 less and do 7 for 120. So 7 times 6 is 42. Carry the 4. 7 times 1 is 7. Plus 4 would be 11. When I subtract this, I get 8. Add another 0. Bring it down. And it looks like it's going to be a little less than 7. Probably, I'm going to go for 5. Yeah, and 5, 30. Carry the 3. Yep. So we get 1,875 10,000ths. So that's the way that it'll work no matter what, guys. If we have, you can always divide numerator by denominator. All right, now the decimals we've been working with so far have been terminating decimals. They had an end to it. But we do have ones that don't end, and we call those repeating decimals. Now, repeating decimals have a pattern in their digit that repeats without end. And when we don't want to have to keep writing it on and on and on if it repeats without end. So we use something called bar notation to have a shorter way to write it. It's a bar or a line placed over the digits, just the digits that repeat. So we're still, like if we're going to take 5/12 and we want to change a decimal, you can still use that dividing numerator by denominator. That doesn't change because 12 doesn't even go evenly into 10, 100, or 1,000. So we would do 5 divided by 12. So 12 can't go into 5, so obviously we're going to add a decimal and a 0. Bring my decimal up in my answer so I don't forget it. 12 will go into 50 4 times. We get 48. When I subtract, I get 2, so I'm going to add another 0. Bring it down. 12 will go into 20 once. 1 times 12 is 12. We subtract, we get 8. So I'd add another 0 and bring it down. Now 12 will go into 80 6 times. 6 times 12, well, 6 times 2 is 12. Carry the 1. 6 times 1 is 6. Plus 1 is 7. So I get 72. Now you notice my remainder again is 8. And if I add another 0 and bring it down, I've got another 80. So it's just going to be 6 kind of happening over and over again. But I don't want to have to write that out. So the better way to write it is with a bar. So we would have 0.416 and just 1 6, and we put a bar only over the 6 because that's what repeats, and that's how you'd write a repeating decimal with bar notation. All right, now let's look at this next one. We have -2/11. Now, a negative really doesn't affect how we change a fraction to a decimal. We just know we're going to have a negative in our final answer. So we would take 2 and divide it by 11. So we're going to add a decimal point. Bring that decimal up in our answer. 11 will go into 20 once. So 1 times 11 is 11. 20 minus 11 would be 9. We're going to add a 0 and bring it down. Now 11 will go into 90 8 times. 8 times 11 is 88. We subtract that, we get 2. Now we can add a 0. Now you might be seeing already I got another 20. So here's where we can see, let's double check, make sure it repeats. 11 will go into 20 once, that's 11, subtract, again we get 9, adding a 0, bringing it down, and again we have to do an 8. So we do get a repeat here. Okay, so in this case, our final answer is going to be, it's going to be 18 hundredths with a bar over the 1 8 because that's what's repeating. We got 2 numbers repeating there, so we have to put a bar over both of those. Okay, so let's flip it over and go to the next page, guys. Oops, I almost forgot. This was a negative fraction. I gotta make sure I don't do this. This should be, this should be a negative. I forgot to put my negative sign. So guys, add that negative sign, and now we can flip over to the back. Okay guys, on the back here you notice there are some practice problems. practicing what we just did. So why don't you guys try these on your own, pause the notes, and then I'll go over them real quick. But try these 4 problems, and then we'll go over them. Okay, and pause in 3, 2, 1, go. Okay, hopefully everybody tried these on their own. Let's go over these so you can check your answers. Now the first one, 7/20, we can do equivalent fractions because I can do 20 times 5 to get 100, and then I'll have to do 7 times 5, which is 35. 35 over 100 is 35 hundredths. Now, 5/8 doesn't work as well because 8 doesn't go evenly into 10, 100,000. So we're going to do that way that always works. We're going to do 5 divided by 8. I'm going to add a decimal and a 0. 8 will go into 50 6 times, which gives 6 times 8 is 48. We subtract, we get 2. Bring down a 0. We're going to add a 0. We're not quite done yet. 8 will go into 20 twice. 2 times 8 is 16. Subtract, we get 4. We're not quite done, so we have to add another 0. And what works out nice is 8 goes evenly into 40. So we get, it'll go in 5 times. So we get 625 thousandths. Okay. Now, 12 over 32. Now you could go and divide 12 by 32 right off, but some of you might have noticed is that that actually can be simplified. And if you can see that can be simplified, it's kind of nice to do that. 12 and 32 can both be divided by 4. You get 3/8. What's nice about that is you can 3 and 8 are easier numbers to deal with. We can divide 3 by 8 and it's the same thing. If you wanted to did 12 divided by 32, that's fine. You still should end up with the same answer as I'm going to get dividing 3 by 8. So I'm going to add a decimal and a 0. Bring up that decimal, and 8 will go into 30 3 times. 3 times 8 is 24. We subtract, we get 6, so I still have a remainder, so I got to add a 0 and bring it down. 8 will go into 60 7 times. 7 times 8 is 56. We subtract, we get 4, so I still have a remainder, so I'm going to add another 0 and bring it down. 8 will go into 40 evenly. It'll go in 5 times. So we get 375 thousandths. Now you should have gotten the same answer as if you did 12 divided by 32. But you notice how simplifying something like that can make it easier numbers to deal with. Now our final one here, -5/6, is we're going to do 5 divided by 6. And it doesn't go evenly, so I'm going to add a decimal 0. And I don't want to mess it up like last time, so I'm going to put my negative sign in right off. So 6 will go into 50 8 times. 8 times 6 is 48. Subtract, we get 2. We've got a remainder, so we're going to add another 0 and bring it down. 6 will go into 20 3 times. 3 times 6 is 18. We subtract, we get another 2. And if you notice, oh, I see I got another 20. It's going to be another 3. Let me put my answer down here. So I have a repeating decimal. So it's going to be negative 0.83. And I'm going to put bar just over the 3 because it's only the 3 that's repeating. So hopefully you guys did pretty well with that. Let's move on and talk about how we can compare fractions. So let's see. Let me move this up. Oops. Let's switch it to, let me move it. Okay. Now, when you compare fractions and decimals, you basically have to have them in the same form, or you can use a little kind of shortcut, called cross products. In equivalent fractions, okay, cross products are equal. So, like if we were going to compare 5/8 to -5/8 to -6/9, a pretty easy way to compare them is to multiply across the diagonal. I could do 5 times 9, and I put it up near my numerator. It would be a -45 because we have negative fractions here. And we could do 8 times 6, which would be a -48. So -45 would be greater than -48. So this is greater than. Now another way to do it is we could change both of these to decimals. Now if basically but that's a little more work because you got to divide each of those because neither of those go evenly into 100. Or you might see like this simplifies down to 2/3, and that might be one you memorize. 2/3 is 0.6 repeating. And then negative 5/8 is negative 0.625. Okay, so you can see where cross products might be a little bit easier. Now, here, let's look at this one. For both fractions, I think cross products are easier than changing them both to decimals. Now here, you could do 40 times 5, which is 200. And then 12 times 16 is 192, so this is greater. Or you might have seen you could have simplified that 16/40. But, so cross products are kind of easier when you're just comparing two fractions. But when you're comparing a fraction and a decimal, sometimes it's easier to get them both to decimal form. So let's look at these examples. Like for example, if we're comparing 1/4 and 2/10, 1/4 is a pretty easy one that you hopefully maybe have memorized. That would be 25/100. Now 25/100, now 2/10 is the same as 20/100. We could add any zeros after that. So 25/100 is going to be greater than 20/100. Okay. So here, 13/20 compared to 7/10. You really want to get them both in the same form. If you've got one that's a fraction, one that's a decimal, you either want them both fractions or both decimals. So like, for example, I see 20 goes evenly in 100, so I'd go 20 times 5 would give me 100. And 13 times 5 gives me 65, so this is like 0.65. So 65/100 would be less than, this would be 7/10 or 70/100. So that would be less than. But when I have both of these as fractions, to me it's easier to use that cross product. So here I'm going to have 7 times 5 would be, now we got both negatives, so I'm going to do a negative 35. And then 11 times 3 would be a negative 33. Oops. So that would be a less than, because negative 35 would be less than negative 33. Okay, guys, so what I want you to do right now is try these 4 practice problems on your own. And then by first pause the notes, and then try these, and then start the notes back up so you can check your answers. Okay, pause in 3, 2, 1. Okay, guys, hopefully you tried these on your own. Now let's check answers. So negative 7/15 and negative 5/12 is going to be a less than, because if you do cross products, 12 times 7 would be a negative 84. And then 15 times 5 would be a negative 75. So negative 84 is less than negative 75, so negative 7/15 is less than negative 5/12. Now, this one, comparing 7/8 and 87/100, you probably want to change them both to decimals. So we could do, probably want to change that 7/8 to a decimal. So we're going to do 7 divided by 8. 8 will go into 78 times, you get 64. Subtract, you get 6. Add a 0, bring it down. 8 will go into 67 times. 7 times 8 is 56. Subtract, we'll get 4, bring it down. There's 875. So this is 875 thousandths, and this is really 870 thousandths. So this is going to be greater than. Now with number 3, they're both fractions, so I'd probably use cross products. 25 times 11 is going to be a negative 275. 15 times 13 is a negative 195. And since we're dealing with negatives, negative 275 is going to be less than negative 195. And then here, for the last one, we've got negative 11/40. Now if we wanted to change that, we could do 11 divided by 40. Add a decimal. Now 11 will go into 110 twice. Now something you might want to see, because it'll go in 80 times and we'll have 30 left over. You can almost stop there, because we'd have a negative 2/10 and this is a negative 2/100. You know, this 2 is going to be bigger than that. Because we have negatives though, it's actually going to be less than. You don't even have to keep going. All right, guys. Hopefully you fill this all in. We're going to work with some of this in class together tomorrow.